So the Triboelectric effect sounds kind of complicated, but really all it's stating is this. There is a list of materials that you see here that is in order from top to bottom. And at the bottom are objects that have a low affinity for electrons. Means they don't want to hang on to them. So they will easily let them go. Materials like rabbit fur, which is what we use, asbestos, even glass and wool, things like that. Now up here at the top, you have a high affinity for electrons, which means they will easily take them. In fact, they want them. So if we were to think about this, in as far as this list is concerned, electrons like to move up the list. Electrons will hop from human skin to cotton. They'll hop from glass to wool. And in fact, the further the two things are apart, like rabbit fur and, rubber, there's going to be a much bigger jump. So the further they are apart, the greater the amount of charge transferred. So let's take a look at how we might answer some questions about this. So it is known that object B, by the way, what you'll see here is the answer already given, and I'm just explaining how, when you click on that object, how to select the right choice. So object B has a greater affinity for electrons, okay? So it hangs on to electrons than object A. So it has a greater affinity, so A will let go of electrons more easily when rubbed up against B. B will take them on, A will give them up. And so what happens here is that the electrons flow from left to right, from object A to object B, meaning that object B will acquire a negative charge, and because of the loss of electrons, object A is positive. All right, here it's known that object B has a weaker affinity for electrons. So a weaker affinity means it will let electrons go. Affinity means that it hangs on. So it'll, in this case, object B has the weaker affinity than object A. So when they're rubbed together, the electrons will leave B and go to A because of their relative difference. So in this case, A wants electrons and B lets electrons go. And so that's just based on those two materials, rubbing them up against one another, that's where the electrons will go. They'll move off of one onto the other based on the relative affinity for electrons. Let's take a look at the chart at the right. Now it ranks materials according to their, again, relative affinity. And so remember this, electrons move up the list. They'll move from one object to the next, bottom to the top. So let's say we have material A is rubbed with acrylic. And material A becomes charged positively. Okay, so when we combine acrylic with material A, and you can organize this any way you see fit. If you look at that, you rub material A with acrylic, and the exchange of electrons is like this. Material A becomes positively charged. That means that electrons must have flown off of A onto B, or onto the acrylic. Now material A is then rubbed with silk. And material A becomes negatively charged. So that means the electrons flew off of silk onto A. Okay. So we say that electrons move uphill. So if we look at this and we say, all right, well, if silk gave away electrons, then this tells us that A is above silk. Now, if A gave away electrons, then this tells us that acrylic is above material A. And so A must be in here somewhere, right? Because silk gave up electrons to A, and A gave up electrons to acrylic. And so somewhere between acrylic and silk is where material A is located. Let's take a look at another one. So material A is rubbed with polyester. As a result, material A becomes positively charged. Okay? So another way of organizing this, I'm going to show you just a couple different ways, but I would definitely write this out. So in this case, A gives up electrons to polyester, becoming positively charged. Now material A is then rubbed with aluminum. Once more, it becomes positively charged. Okay. That means it gave up electrons to aluminium. Where should material A be in the series? So if we look at aluminum and we look at polyester, in both cases, the electrons were given to polyester and given to aluminum. That means that, remember that electrons move up the chart. So if electrons were given both to aluminum and polyester, then I would say that material A is somewhere down here, because it's always giving up electrons to those materials. So in this case, we have experiments that are being done, and we got to figure out how to organize our materials. So here's the results of the test. So A, when rubbed with B becomes positive. So B gives up electrons to A. A and C are rubbed together. C gives up electrons to A also. Now B and C are rubbed together. Then B becomes positive, so B gives up electrons to C. All right? So I think A is up top because it wants the most electrons, because it's most E-loving. That's kind of, it's taking all the electrons off of those. Now, C gives up electrons to A, B gives up electrons to A, but then B gives up electrons to C. So this is the way I would organize it. All right, B gives up electrons to both A and C, but C takes electrons from B and gives them to A. So it's somewhere in the middle. Last one here. Let's organize them. All right, so if A and B rub together, A gives electrons to B, C gives electrons to A, D gives up electrons to A, and D also gives up electrons to C. So if we look here, A gives up to B, C gives up to A, D gives up to A. Now, B was not rubbed with any other object, but you can tell here that it looks like D is always trying to give up electrons. And if we, start at the top, A seems to get all of the electrons, but it will eventually give them up to B. So I think B is the most electron, has the most affinity, followed by A, and then you can kind of look at it in order of, okay, what gives up electrons to what, and C gives up to A and D gives up to C, so you can reason it